All right, going back over our schedule, today we're going to be doing guessing the meter error. As the guys that I've talked to out in the field, this is this is probably one of their favorite things. Meter technicians love to be detectives, and so I think you guys are going to really enjoy this class. Next Tuesday, we're also going to talk about the differences between the 6S and 9S meter, really as far as the KW calculation and what happens when you have an imbalanced load on a 6S versus a 9S. What kind of losses can we expect? I don't think anyone I've talked to, I've been very shy about my distaste for non-Blondell services, mostly because there's so many ways you can mess it up, and it's bad, really bad business to make the assumption that you can make everything be perfect all the time. And as we know, as our field guys know, that's not going to happen. So I want to go over that. We're looking at a possible alternative, if we can't get this worked out, but right now we're going to stick with this one. And then lastly, Thursday, don't forget, we're going to be doing a Powermetrix virtual tour. That's going to be, for those who aren't able to travel, you can actually get a virtual tour through our facility, and you'll be able to meet some of the key personnel that's involved with designing your product and servicing your product. So make sure you join us for that. Also, we're still doing demos on a private basis. So if you guys would like to be able to see a product or the training bench, and you've got maybe specific applications or questions that you have, feel free to click on the Contact Sales button, and we can schedule a demo just for you. Fun fact, downstairs, I'm actually upstairs in my office today, but downstairs in the training room bunker, John Jones is doing a private demonstration with a potential customer right now. So it's working out well. So what we're covering today is I'm going to be going through 10 real scenarios. And I do kind of want to point out that this class is probably going to be geared more towards your advanced technicians. So those of you who have a couple years of field experience and troubleshooting, I'm kind of making the assumption you guys have that. This may be a little bit challenging for you new guys, mostly because you may not know what an ideal situation for a 2S meter looks like, or a 3-wire delta using a 5S. So I'm going to make a few assumptions, but hang with me because I will be going through each solution as to what the problem is and how would you troubleshoot it or look for it next time. So each scenario, I'm going to show PowerMaster screenshots, and I'm going to show each one is going to show the vector diagram, the waveform, the multimeter screen, the customer load meter test, and if it's a CT rated meter, I'm also going to show the CT test. If it's a self-contained, obviously we're not going to be showing that. And like I mentioned before in the chat, I do want to encourage participation. So as I go through each one of these scenarios, feel free to enter your answer in the chat area, and I'll give anyone kudos who comes up with the right answer. Some of these are going to be fairly easy. Some of these may be a little bit harder, but again, with the tools you have, I think we can all get through this and be better technicians out in the field after this is over. All right, so you guys ready? Let's do it. By the way, John Jones just finished up his webinar, so he's up here now annoying me.
I haven't even said a word. I'm just sitting here.
All right, so first scenario, I've got a 2S meter. I've hooked my Powermaster up to the service, and I'm getting some unusual information. Problem number one, looking like my phase relationship doesn't look exactly right. So what should we expect to see on a 2S meter? We should have phase A in line, but where should phase B typically be for an ideal situation? Also notice that if you look at my watts per phase, I've got positive watts here, but I've got negative watts here on this B phase. Lebo, you're on the right track. Good job, Matt. Good job, Robert. So these are kind of the clues that we're looking at, right? So you've got this phase on phase here. I've got a sinusoidal waveform where everything is at phase with each other. But look what it's doing to my kW. I'm virtually getting 0 kW, and that's why when we try to do a meter test, you never get a pulse, right? So the good news is a couple guys have already mentioned it, the answer in the chat area, and they're exactly right. So this is a 2S meter, and so what happened was when the technician came in, they pulled the phase B current, and when they made the connection to the meter base, they actually had the polarity backwards. And so what happens is that when you have these two phases lined up with each other, they effectively cancel each other out because the meter is expecting to see the phase B 180 degrees out of the phase A. And effectively it sums, but in this case we are subtracting because their phase B is out of phase. And so the meter never does turn and your customer never gets a bill. Great for the customer, not great for the utility. All right, so that's what's going on. So we just effectively cancel out the phase relationship and the meter never turns. So when you're hooking up your equipment, the vector diagram, your power factor values should be fairly obvious, but if you're just using your eyes, you'll notice the meter never turns. That should be probably your number one suspect. But when you hook up your Powermaster, you verify that, right? All right, good job everybody. Moving to the next one. Same service type. We're actually dealing with a 2S meter. It's a single phase service. So my vector diagram looks better. My waveform looks better because everything's 180 out from A. But my meter test looks okay. It's slightly out. Is there a problem here? Does anyone see anything wrong with this site? I'll show you a clue in a second. Here's some clues. What we got here? Remember, it's the 2S meter. And this meter is a multi-range meter. What's going on? For those who can't read the multimeter screen, we're measuring around 120 volts on voltage A to B. Yeah. Robert, good. Jim, good. Gigi, I think you got it. So what's going on here is we're not missing a voltage. We're just tapped on the wrong side of the transformer. So when the installation was hooked up, they pulled off a 120 source instead of a 240 source. So if it was a single range meter like some meters are only powered off the expected 240 volt phase, they won't power up. But in this case, this meter was a multiple range meter, so it actually did power up at the 120 volt phase to phase source. So that's problem number one. Problem number two is that what's going on is that you're basically getting half the expected kW. So the customer is in effect being billed half the current, and therefore half the revenue. So what do we look for? We obviously look for those voltage values. Notice that the meter test doesn't really show you that much. Maybe it's slightly out, but if you're looking at the kW, that should give you an idea, right? If it wasn't a multi-range meter, the meter would never power up because it can't get those 240 volts to those two legs. So that was going on with that one. Good job, Gigi. All right, next scenario. We are now at a 12S meter, and this 12S meter is metering a 3-wire network. Now, a 3-wire network is really coming off of a 4-wire Y distribution, but only pulling the A and B leg off of it. So it's only using 2 elements of the Y service. And so effectively, we should see what? We should see probably 120 degrees spacing between each. I'm not sure we're seeing that in this case, right? What are some of our clues? First thing, something doesn't look right on my phase B current. Looking at the waveform, I've got a really wide phase problem, and notice looking at here's my phase A column here, I've got positive watts, but phase B I've got negative watts. Effectively what that does, I'm canceling out my kW, and therefore if I have no watts, my meter's not going to turn and I'm not going to test, right? Colin, good job being on B current. Lebo, phase B reversed. Hook'em horns, must be my buddy in Texas. Out of phase. Andy, phases are off. Yep, you guys got it. This one is a fairly easy one to determine. So again, this is a 12S meter. The issue is when they were pulling the line, they tapped the wrong polarity on phase B, and so that cancels out the kilowatt hours, and therefore your meter doesn't turn. So hopefully, when the installation occurs, the technician or lineman, when they insert the meter into the socket, they should not see the meter turn. Usually that triggers their troubleshooting. Like, okay, well, let's try to figure out what's going on. But sometimes, especially if you're dealing with a new guy or possibly a contractor, they'll put the meter in, see it powers up, and then leave, and you'll never catch it until the next billing cycle comes around. So that's what's going on with that one. So good job, Hammy, Lebo, Colin, Hook'em Horns, and Andy. Good job, guys. Next scenario. I like this one. This one is on a 16S meter. Can anyone tell me, even though the vector diagram looks kind of screwed up, can anyone tell me what service type this is using a 16S meter? James, I'm going to kill you, James. You shouldn't be giving answers away.
James who? Our James?
Yeah.
Naka?
Yeah.
Is it
Yeah. Hammy, Robert, Andy. Yeah, I think you got it. What it is, it's a delta. It's a 4-wire delta. on using a 16S meter, and that can be done. This is an interesting one. I like this one a lot. So, so here's some of our clues that we're seeing. So again, it's 4-wire delta. You got a high leg 208, right? So that's what the deltas are typically used for. We actually, in our building, we actually have a 4-wire delta service here, and we got a high leg we used on some old motors that we had back in the day, and that was the reason why we had it. But in this case, similar situation, 16S meter. Some of the clues that we're seeing is, where is my C element? I don't see it on the vector diagram. Don't see it here in my waveform. Notice that I've got no voltage and no current on that C element. But meter registration is coming out, right? Right? The meter is still turning. It's still seeing the same kW based on what's on A and B phase, still moving. And accuracy doesn't look that bad, right? Is it correctly accumulating the right watt hours? Nope. So what happened in this case? Does anybody have any idea what this is? It's kind of an unusual one, I will admit. Not an easy one. But what happened on this one was, have you guys ever used those old 16S mechanical meters that had a single range? Well, if it's a single range, each element is maxed out at 120 volts phase to neutral. So when you put this mechanical meter into this high leg delta, after a while the C leg finally blows because it's oversaturated. Now the service is still operating fine. In this case, it's a metering problem, and when that final element blows, that's when you see your potential go out and your current go out, because the entire element's gone. Because if you remember, on a 16S meter, both potential and current are tied to the same element. So that's what happened here. So they had an old mechanical meter, plugged it into this Y service, and over time the C element finally blew because it was a single range meter. Now if you had a multi-range meter, 120 volt to 480 volt, you probably would never see this problem. But if it's single ranges, definitely would see the issue. So how do we find this one? Meter will still turn, right? But when you hook up your equipment, you'll see a bad vector and you'll see no watts or on C phase, which is because there's no element on C phase. I like this issue. It's pretty cool. We actually saw it. One of our guys down south brought it to us. All right, next one. Nobody got that one. Sorry. You all failed. All right, moving on to CT rated service. This is a 3S meter. So you're looking at the vector, looking at the waveform. That should give you guys some clues of what's going on. Anybody have any idea what's going on here? You guys may not know this, but I've got like a 20-second delay between when I say something and when I get a response in the chat area. So if you hear some dead time, it's my fault, not yours. Not a bad guess, John, as far as the current flowing through the same direction. That's not a bad guess, yeah. Ooh, Robert's pretty warm. Why do we think it possibly could be a bad CT? Right? We got no current here on the secondary, and we validate that when on our CT test, we're seeing no primary amps and no secondary amps, right? single phase service, one element to the meter in one CT. So yeah, Robert, good job. This one was, it was a phase fault on the CT. The CT actually saturated it and completely failed, and therefore there was no current flowing to the meter. In this case, fairly obvious. If you walk up to the site, you can see the meter was not turning. In this case, the CT was damaged, but it wasn't fairly obvious. So that we had to determine it when we hooked up the Powermaster and be able to see what was going on. So good job, Robert.
Is this where you toggle them, go to your primary vector so you can look at the primary and see?
We failed on both.
That's what I'm saying, we're failing both. But I mean, did you have that on the picture?
Mm-hmm.
Oh, I didn't know that. I can't see it.
All right. Moving on to the next one. We're doing this is scenarios for a 5S meter. Now a 5S is probably the most dynamic meter we have out in the field. Can anyone tell me what kind of service type we're measuring right now? Am I not getting audio? Good job, Hammy. Good guess. Yep, we are. This is a 3-wire ungrounded delta, correct. So with a 3-wire delta, this would be unusual to see, right? So what are some of our clues that we're seeing? So I've got pretty bad power factor on C phase. If I look at my watts, C phase element, I got negative watts here. So I'm basically canceling out once again. The meter would not turn because my meter is I'm getting no pulses because my meter is not moving. But the question I have is, so I think I know what the problem is, right? It looks like I've got, maybe reversed phase. But why am I getting a good CT test? Can anyone figure that out? Vector looks bad, multimeter looks bad, but my CT test looks great. So why is that? Could it be that if you think about it, so I've got my line that's coming in. If the polarity is wrong on the primary, would the polarity be wrong on the secondary? So I think we can all agree, and CDA said it first, flex backward, yeah. CDA said it first, that with the C phase is 180 out, that's exactly right. So I think we can all agree on that. Flex backwards, nope. The flex is in the right direction. But in this case, what was going on is this came at the distribution side. So the primary coming off the distribution tapped to the meter, tapped to the CT, I apologize, was at the wrong polarity. So if you got a wrong polarity on the primary side, it goes straight to the secondary, right? So I've got a bad polarity on the primary, a bad polarity on the secondary, and in this case, two wrongs make a right. That's why your CT test comes out correct, because it's looking at the polarity between the secondary current and the primary current. And so if it's matches, even though it's wrong, you're going to come out with a good CT test. So one thing to look at is that you have to use all of your tools to try to figure out what's going on. Now let's say, for example, that the primary was right coming in from the CT, but the mistake was made at the secondary, where maybe at the X1, X2 connection, the technician had the polarity wrong and went to the meter. That would cause a failed CT test, because in this case, your primary and your secondary are 180 degrees out of each other, and therefore you would get a polarity reversal error on the Powermaster. So you get a fail. But again, in this case, I've got the primary and the secondary at the wrong polarity, so the CT test comes out correct. Or not correct, but it passes because the polarity is at the same phase. Interesting one, I always thought. So what do we look for? Meter won't turn. There's no KW, so the meter won't turn at all. But the odd one is that your CT test will come out good because the polarity, again, of the primary and secondary are matching. So interesting, I thought. Number 7. This is a 6S meter. It's used on a 4-wire Y Z-coil, a 2.5 element meter, but the base service is a 4-wire Y. So what sticks out? Looking at the vector diagram, it looks maybe that my A-phase current is lower than my secondary current. Now that's not unusual. Sometimes we have imbalanced loads, right? And it's displaying on both the vector diagram and the multimeter. Meter test comes out perfect, right? Perfect. No problem there. But what's throwing me for a loop is my ratio test. So when I ran A phase, I got a fail. But B and C look good, right? 205 CT looks good. But why the heck is my phase A CT measuring twice what it should?
Oh, Mr. Carter.
So I've got a 100% ratio error here, right? But everything else looks good. Vector, multimeter, meter test looks good. But I got a jacked up A-phase CT test for some reason. Actually, 2 reasons. I'll explain why. But in this case, there was a specific reason as to what happened. Somebody's killing me.
Knowing you, I bet it is.
Lebo, good guess. That could happen. Yeah, Lebo's made the suggestion that we could have, incorrectly wrapped our flex 2 times. That could present a false error, but not true in this case. Ooh, Hammy, I think you may have got it. So Hammy says, without seeing the numbers, I would guess a wrong ratio CT. You got it, Hammy, good job. What happened is that when the line crew were installing this service, when they were at the meter shop, they grabbed 3 205 CTs right out of inventory. installed all three of these 205 CTs, and then didn't discover the problem until the technician went out and did his standard testing. So on the nameplate, believe it or not, it actually said 205. It was stamped in yellow, 200, but in reality, from the manufacturer, came back incorrect. It was actually a 405 CT. So technician didn't do anything wrong. The lineman didn't do anything wrong. They installed what they thought was a 205 CT. But what happened was the manufacturer actually shipped a wrong CT. So that's what happened in this case. But there also could be another problem, which I've seen this happen before, is that if you have a dual range CT, let's say a 200/405 CT, and the lineman connects to the wrong tap on the transformer, let's say like the 405 tap, you can get this same answer. So those are the two problems you can find. That problem actually is more likely to happen, that they tap off the wrong tap on the CT. But there are cases, believe it or not, where we've ran across from the CT manufacturer, they just had the CT's value stamped on the CT wrong. And I've seen this happen before. They actually had the number written on the CT wrong, but if you look at the nameplate's correct. So it was just during the printing process, I guess, when they stamp on the CT, they just stamped the wrong number, or it may have gotten into the wrong conveyor belt, when they were doing this stamp. So good job, Hammy.
Can I say something?
Yeah, hang on.
No, I don't need. Do I need?
I just want to make a quick field comment on that one, which is if you don't enter in the size of the CT, you won't get a fail. It'll give you a pass on them, okay? Because it's just looking at the ratio and how close the ratio area is. So on the one Chris showed, it showed a fail on it. That would have been if you entered the size of the CT in there. I just ran one a little while ago. If you don't, you know how the Powermetrix is smart enough because it looks at the ratio and then it sizes the CT and makes an assumption there. Well, if you don't put in that there were 200 to 5s on this site, it wouldn't have given you a fail on that. They would have all passed.
So again, what Jones is referring to is when you're setting up the site in either a meter site manager or on the PowerMaster. In this case, you need to go in and select the transformer, the 405 or 205 CT in the site. Otherwise, we would give it a pass as long as the measurement was within specifications. So it may be a false positive. You just may look up and see, well, I got a pass, but why the heck is it a 405 ratio? So it should, hopefully you should use your eyeballs, try to figure that problem out if that happens. But in this case, the technician actually selected a CT in the database and then ran it. And then when the PowerMaster saw it and saw, oh, this doesn't match what's in the database, so this has got to be wrong. So good info. Thank you, John.
Yes, sir.
All right, 2 more to go. This is on a 9S meter. It's a 4-wire Y. So looking at these things, oh, this one should be easy, right? What do we see, right? Phase angle is 180 off. A, B, and C. Looks jacked. Power factor's negative. All right, I know what this is, right? You know what it is, John?
You got polarity reversal on all 3 phases.
You think so?
Well, wait a minute. Whoa. You're saying that now. I know you too well, Mullins. You're saying that. Hold on now. Let me look.
Get up here and look. You're setting me up. Hold on.
Think it's a CT backwards? Andy thinks the CT's backwards. What do you think?
Okay, if you look at the vectors are telling you you have polarity reversal on all 3 phases. So yes, they could have put all 3 of the CTs in backwards. They could have wired all 3 of the CTs wrong, but it's definitely consistent polarity reversal on all 3 phases, 180 degrees out. And you're getting a negative registration, which tell you it's seeing negative watts. So that makes you should see negative, yeah, there it is, negative over there. That's right.
Well, we're missing one key information, right? So meter test, negative percent registration, right? It's a bidirectional meter.
Yep, clearly it is.
So when I run a CT test, why are my CTs passing? I'm 180 out, but why are my CTs passing?
Really? Oh, that's a dirty dog. You're a dirty dog.
I want to say two people actually call this one out. Good job, Hammy. Good job, Andy Ray. Excellent detective work. We have a negative registration, but our CTs are passing. Therefore, we know that the polarity and the secondary are in line with each other, correct? So is there a problem? The answer is no. There is no problem. This one was actually at a solar site. And in this case, the meter was registering received energy. It was actually in generation mode. And so the reason why your CT tests are passing is because, again, like I said, both the primary and secondary, but the primary coming in and the secondary side from the CTs are actually in phase with each other, and that's why your CTs are passing. So what do we look for? Vector diagram, meter registration, those are pretty obvious. You're going to see negative polarity there. CT tests, you're going to see a correct because they're all in the same site. But here's a duh. Are you at a generation site? Most people know that, right?
Yeah.
But that's a kind of a duh statement for the technicians. But think about if you're in management, and so you're getting this data coming in and you're reviewing the data, you may or may not know this. Yeah. You may or may not know this. So your manager may look at it and say, what the heck's going on? Why am I getting negative registration? Well, this one was actually a solar site and during generation mode. So that's what's going on with this one. So no problem here. I was just kind of threw you guys for a loop. But good job, Hammy. Good job, Andy, on catching this one, though.
Andy Ray got that?
Mm-hmm, yeah.
I'll get a phone call.
All right, here's another one. A little bit easier, I think. So this is, again, a 4-wire Y 9S meter. All kinds of alarm bells should be going off, right? So vector diagram, I'm not seeing matched currents here, right? So I've got nothing is matching in phase with my voltages and currents. Negative watts. Meter test is actually running backwards. It's the bidirectional meter again. But unlike the last site we looked at, this actually, all my CD tests are failing. I'm getting a 120-degree phase error on each one of these CTs. So what do we think is going on with this site? I can tell you it's not a solar site. Yeah, good job, Andy. Wires are swapped here. Actually, it was a clockwise rotation. So when they pulled off the line off the primary side, when they made the connection to the off X1, X2 to the meter base, they actually did a clockwise rotation, whereas the C was B and B was A, and they just kind of rolled it around. And so that's what happened here. So when they set the meter, the meter would turn backwards. So they may or may not understand that's good or bad, but that's what happened in this case. But your vector diagram and your power table will show an obvious problem we got here, that we had a clockwise rotation problem.
I don't know that it happens much, but John mentioned if it's not a bidirectional meter, it can zip.
Yeah, good point. John mentioned that if this wasn't a bidirection meter, the meter wouldn't turn at all because you were getting negative watts. But most of the 9S meters we have out there today are all bidirectional. So you're going to see either negative, received or delivered energy. It's going to register that. All right, last one. This one's probably the hardest one, I'll admit, but I'll kind of help out with some of the clues we got. So again, we're at a 4-wire Y, and this is a 9S meter, but some things are popping out, right? So let's look at our vector diagram. Something doesn't add up here. My C current is actually lined up with my B voltage, causing a power factor issue there. Current B is 120 degrees off from voltage B. That's a problem. A looks okay though, right? Clues there. Clues here. Positive watts on A, negative watts on B, and I got nothing on C. Notice I have no voltage on C phase at all. And I'm only measuring 30 watts on this meter. So the meter is turning very, very slow, if at all. If you notice, if you look at the meter test here, it actually took me 620 seconds to get 3 pulses off of this meter. So it took a long time for that meter to turn. But the meter test isn't bad, I would say. It's not horrible. It's 99.39. It's outside the spec of the meter itself for a 0.2, but it's not horrible. In the CT tests all look good. Robert. Ooh. Somebody got it.
Who's Robert? Which Robert?
Or rep it, you go. I see a good guess from Andy. Andy guessed that it was a missing potential and the CT wired wrong. Good guess there. But Robert and Hammy, good job. That one is, I didn't think it was, that was an easy one. So yeah, what's going on is you got a 9S meter. Oh, what happened was, I'm sorry, the technician was at a 4-wire Y Z-coil site. He pulled the 6S meter and he had a 9S off the truck. No big deal. It fits, right? I stick it in the socket, it works.
Oh, yeah.
So I stuck my 9S meter in there in this 6S socket, and that's what happened. So on the next slide, I'll show the differences on the potentials as to why we're getting this kind of error. But roughly, you're losing about 20% in lost revenue, mostly because you've got a phase problem on B phase and you got no C element at all. So what are we going to look for? You look for that vector diagram. Meter registration is slightly off, and the CT test looks good, but your vector diagram is throwing some errors on you. So if we look at the difference between a 9S and a 6S, the 9S over here on the left and the 6S over here on the right, VA matches on both meters here on this leftmost potential, but on my 9S, on my B phase potential here, once I hook it up to a 6S socket, I'm actually looking at the C potential on this end. That explains why I've got that phase problem between the current B and the voltage B, right? That's problem number one. Now here's a bigger problem. On my 9S meter, I've got my C potential, and when I hook it up into the 6S socket, I'm actually looking at the K on the KYZ, effectively canceling out any kind of voltage measurement at all. So you can see how it kind of shifts. You've got A, B, C. On the 6S, I've got A and C, and then I go right into my KYZ connections there. So that's why you're getting no C element at all, the potential element, and you're getting a phase problem on your voltage B because it's incorrectly thinking it should be lined up with C. Good example. Good job, Robert, and good job, Hammy, on getting this one. That one I thought was a little bit more difficult, I would say.
Yep.
All right, so in summary, just like John Jones always says, make sure your connections are right. So when you hook up to this site and you see there's something wrong, make sure your Powermaster is hooked up correctly. Make sure you get the right service type selected before we start calling and find out what's wrong. So again, double check your connections to make sure you got everything hooked up right. Use all of your tools. As we've seen, looking at one screen of the Powermaster, the vector, or looking at the meter test, it's not going to tell you the right answer. You need to look at the entire picture. This is why we always preach the idea of integrated site test, because we're looking at everything from the secondary to the primary, how the meter's performing, how the CT's performing, and all that gives you a final solution where you can determine what the problem is. Looking at one component, like looking at just the meter test, is not going to get you there, right? We only in one example, I think I had one meter problem. That was it. Rest of them were either wiring or socket-related problems. And don't be afraid to ask questions. Be a detective. Reach out to us. We've seen a lot of this stuff. We can help you troubleshoot some of this. If you have an engineering staff, reach out to them. They a lot of times they can work the math and try to figure out, this was what could be going on, and they can kind of explain the theory as to why we're getting this kind of problem. So don't be afraid to ask whoever you can to help you with this problem. And to close us out, John's going to do a prayer for us.
Thanks, sir. National Prayer Day. Obviously, we're going to do that, and check out the brain on Andy Ray. Anyway, I'm sure he'll call me here in a little bit. So we're going to go ahead and pray this out, if you guys don't mind. Precious Heavenly Father, thank you so much for this day and this time. Thank you for this great presentation that Chris put together. These are the sort of things that can drive us crazy, but that's why they need us out in the field. These are the sort of things we're those forensic guys that get out there and find it. And Lord, keep all these men and women safe out there in our industry that put themselves on the line. And thank you so much for us starting to see things starting to get a little better in this country. And just be with our government, Lord, because it's things are going to get crazy here before this election. And I just hope that whatever happens, that we see more of you and less of us in this country. So thank you for all these things, and all these things I ask and say according to the will of one who paid it all, my brother Jesus Christ. Amen.
All right, guys. I'll see you guys next Tuesday. Be safe, be good. Talk to you later.